Thank you. So today I thought we'd talk about the Structure SDK, which is a companion development platform for our structure sensor, which I'll talk about just briefly first. So we launched the structure sensor about a year and a half ago and brought it to general availability in the market in June 2014. It's the first mobile 3D sensor, and you can attach it to something like an iPad or another device and instantly add depth sensing. And while a lot of the initial applications were around things like 3D scanning, we've seen more and more interesting work around augmented reality, and we'll talk about all of those today. So the Structure SDK is really about building spatial computing apps. And we see spatial computing as a combination of both capturing stuff from the real world as well as mapping the real world and merging those together. The key features of the Structure SDK starts with 3D scanning capabilities, so the ability to capture dense meshes of objects and people. And then room scale mapping, the ability to capture larger scale environments, again densely mapped. And then the other current substantial component of the Structure SDK is the ability to positionally track, again using a map of an environment. So with 3D scanning, one of the great things about having a depth sensor is that you don't need markers. You're able to instantly start capturing objects regardless of any prior knowledge of where they are or what you want to capture. And in particular, there are a few things that we've done to make these types of applications much more user-friendly and much more reliable in real-world use. One of the key things is tracking. So if any of you have ever used Connect or another device like that to 3D scan an object, you're probably familiar with tracking loss, with the scanning being unreliable or not capturing an object properly. We've integrated multimodal tracking that uses both RGB feedback as well as the geometry feedback from the model to make this more reliable. And finally, we've integrated the ability to capture high-resolution color textures that can be added to these models. Now, one of the cool things about the Structure SDK is that every single one of these foundational components comes with a sample app that's available as code within the SDK to give people a starting point. So within the Structure SDK for 3D scanning, we have a sample app called Scanner, which lets you easily capture an object or a person with dense geometry with full color. And again, it's available as code for that, so that anybody can create an application on top of it. So one thing I mentioned previously was the multimodal tracking we have. So we have a pretty interesting example. Here we have an object which is lacking informative geometry. If you were to use geometry-based tracking, you would not be able to scan this object. However, since we're also able to use color data, we're able to track reliably against the model. So typically a cylindrical shape like this would fail, but as you can see, we're tracking precisely to the model. So the next component I'll talk about is the room scale mapping. So this is something that allows you to capture a larger scale mesh of an area, again without a marker, and again using that multimodal tracking that lets you use both geometry and color data to track against what you're capturing. Because the structure sensor is an active depth sensor and because it's got a known baseline in its optical elements, everything we capture is metrically precise, so you can capture measurements of what you're scanning, whether it's an object or a room. So again, I'll show you, and again, because this is part of our SDK and because we know many developers have not yet developed with a depth sensor, we include a sample app called Room Capture that gives people a foundation to build their own application on top of. And here's a quick demonstration of Room Capture. And I'll note that that wasn't sped up. It's really that fast. It captures models very, very quickly. So the final one I'll talk about is positional tracking. This is something that's become much more relevant lately with the advent of some of the more recent virtual reality systems. One of the unique things about using the structure sensor as a positional tracker is that it can travel with the user and it actively maps the environment. And what that means is it has no spatial constraints. So as opposed to using a system pointed at the user that limits them to, say, a 2-foot by 2-foot area or something similar, you can mount the structure sensor to a headset and positionally track yourself from here to the next city if you wanted to. And in fact, at our second booth location, which is at the top of the escalators, we have this demonstration live, so you can try it yourself. Of course, with an immersive environment like virtual reality, you don't want anything to break the immersion. So within the sample for the positional tracking, we've included drift detection and correction so that the user is always oriented correctly to where they've begun. This includes correction for both rotation and height so that you're always reliably at the level to the ground plane that you're at when you started. The other thing is that our sample here, which is called Unbounded Tracker, was based on SceneKit, which is Apple's new 3D software development kit. And here's an example of positional tracking in action. And what you'll see here again is that as our user moves around, every single movement they make in the real world becomes a movement that happens in the virtual world, whether it's walking, crouching, picking stuff up and throwing it, and it's all just simply done with their natural movements. And it's a pretty fun game to play. We have challenges in our office to see who can complete this the fastest. I haven't won yet. So one thing that a lot of people use for augmented reality development is Unity, and we do have support for that, again with the sample app in our SDK, in fact 2 of them. And of course with the depth sensor you're able to integrate dense scene geometry, and you get real-world occlusions and collisions. Now I mentioned that we have a demo available at the top of the escalators. We're also showing this, which is integrating the structure sensor with a virtual reality headset for the first time. What's unique about what we've done here is we've kind of flipped the augmented reality paradigm on its head. Typically, in augmented reality, you're integrating virtual elements into real-world environments. With our demo, we've done the exact opposite. We've got a virtual environment, but we're able to actually capture real-world objects in real time and integrate them into the virtual environment as you walk around. One of the cool things about the structure sensor is that since we've been on the market for a couple of years now, and we have hundreds of developers on our platform, we've already got a number of applications that have been launched using the structure sensor from companies like 3D Systems and Itsees and Chrysalix. And we'd love for more developers to join us and create their own apps on our platform. And again, we'll be at booth 25 and the top of the escalators. So thank you, and I'm happy to answer any questions.
Questions for Adam?
What's the resolution of the 6 degree of freedom head tracking of the device, or if you put it on the head for the head tracking?
Sure. So the resolution meaning like latency or the degree?
X, Y, Z, yaw, pitch, roll, and latency.
It's a good question. It's not anything that we've calculated yet. All I can say is that the latency is in the manner of, I think, sub 15 millisecond or less. Yeah, the yaw pitch roll, I think, would be dependent on the objects in the environment and how it would react to those.
But no X, Y, Z?
No, it has translation and rotation.
Yeah.
Yeah.
Are you able to track human movement?
So human movement is something that is possible to be tracked. We don't have a component in our SDK yet that does that. If you're familiar with Night, for instance, which was part of OpenNI, that's something that's usable actually with the structure sensor. It's compatible with OpenNI. We have a USB cable that lets it connect to Windows, Mac, Android, and OS X. And so if you still have a build of Night, you'd be able to use that for human tracking.
Other questions for Adam? Well, then thank you very much, Adam.
Thank you.